Another similar example now, that is, if R is a relation on n by n defined by AB pair related to CD by the equation this, AD is equal to BC. I'll write it by question. What is the relation? The relation R, which is between AB and CD, is given by AD is equal to BC. I will write this and I will highlight it so that I don't have to search for it again, because I will rub this up later. For all ordered pairs AB, CD which belong to n by n. Okay. So this is the relation that is given in the question. I have to show that R is an equivalence relation. That means what is the first thing that I have to show? I have to show that AB is related to AB or not. Okay, whether AB is related to AB or not, that I have to show. If it is true, then I will say it is reflexive. Now what is the meaning of AB related to AB? By question. AB related to AB means, what is the definition according to this? This means what? AD is equal to BC. That means first component of this multiplied with the second component of the second pair gives me the same value as the product of the other two. That is the meaning of this. So here first component is this, second component is this. Okay, that means AB is equal to AB, or rather AB is equal to BA. This and this, AB is equal to AB. Okay. So is this true? Yes, it is always true. Why? Because multiplication is always commutative. We will write that, which is always true since multiplication is always commutative. Okay, which is always true since multiplication is always commutative. So what will be your conclusion? Therefore, R is reflexive. Done. Next, we will show whether it is symmetric or not. That means we have to show that if the pair AB is related to, this comma has become too big, is related to CD, then CD is also related to AB. This is what I have to show. Whether this is happening or not, this is what I have to show. How will I show it? Now I am assuming that this is happening. So you will write, since AB is related to CD, it implies what? According to definition, AD is equal to BC by given definition of R. Okay, and therefore this is equal to, this implies AD. What do I have to show basically? I have to show that this is equal, well, this and this is equal to this and this. So we do one thing. One option is we can leave it like this as equation number 1. Now let us check what is happening. Now if I assume that CD is related to AB, then what should I get? Then I should get that first component with last component, CB should be equal to DA. Okay, this in turn means that BC should be equal to AD, and this and why? Because multiplication is commutative, and this in turn means that AD is equal to BC, which is true by equation 1. This is happening, and so if I assume that this is happening, then this is what I get, which in turn means that this is the same as this, so that means this is also happening. Okay, so that is how we justify. Thus, AB related to CD implies that CD is also related to AB. Therefore, R is symmetric. Okay. Next, what will we show? We will show whether it is transitive or not. Okay. So how will we show whether it is transitive? That is, what do we have to show basically? We have to show that, I will write it as subpart 3. So part 3 is that I have to show or required to prove that if AB is related to CD and CD is related to something else, suppose EF, then I have to show whether AB is related to EF or not. This is what I have to show. Okay, that is if AB is related to CD and if CD, if I assume, is related to EF, then I have to show whether AB is related to EF or not. So since I'm assuming that AB is related to CD, what property should it satisfy according to definition? Let me write that. You will write, since AB is related to CD, it implies that AD should be equal to BC by given question or by given whatever. And similarly, since you are assuming that CD is related to EF, it means that C and E, first component and last component, A and D is first over here. So CF is equal to DE. Okay, this also comes by the given relation R. So these are the two things that are being satisfied. Now I have to show whether AB is related to EF or not. So how will I proceed? Or in other words, I have to show that AF is related to BE. Yes. So how to proceed? Now notice, what do I need? I need AF over here. A is here, F is here, B is here, D is here. Right? So one thing you can do is, you can make one as the subject and put it in the other. You will simplify, you will get the result. Or what you can do is, I'm writing this as equation 1 and equation 2. I'm multiplying corresponding terms. Okay, that is another option. Multiplying. That is AD into CF is equal to BC into DE. If this is equal to this and this is equal to this, that means their products also should be equal. That is the concept that I am using. And as a result, what happens? C and D from either side cancels, and as a result you have AF is equal to BE. Okay, AF is equal to BE. What does it mean? It means that AB is related to, because definition says that, it means that AB is related to EF. Check and see. Conversely, that if AB is related to EF, then what equation should it satisfy? It should satisfy the fact that AF is equal to BE, and that is what I have obtained here. So it is correct. Okay. So therefore, what will I write? When AB is related to CD and CD is related to EF, then AB is related to EF. This is what I have obtained. Thus, final result, combining, I'll write little more this side. Thus, combining here I did not mention, therefore R is transitive. You must mention that. The word, I haven't mentioned that. Please mention this. So R is transitive. So final conclusion will be combining 1, 2 and 3. That is, since it is reflexive, symmetric and transitive, hence given R is an equivalence relation. Given R is an equivalence relation, hence proved. Okay, so this is how we prove this equation. Let us do another one. Example number 4, suppose. I'm not writing the entire question, I'm just writing what the relation is. Okay, the relation equation is given by AB related to CD in such a manner if and only if AD into B plus C is equal to BC into A plus D. This is the relation that is given, and they are saying that R is, where R is a relation defined on n cross n, you have to show that R is equivalence. R is an equivalence relation. This is what we have to show. We'll proceed as usual. That is, we will show it is reflexive, symmetric, and it is transitive. These are the three things we have to show. So accordingly, the first one, subpart 1, we have to show that, required to prove that AB is related to AB. We have to show that. Okay. How will we show? Let us check. What does it mean? AB related to AB. I'll write here AB is related to AB holds. Implies, according to the definition that is given, what is it? A multiplied with D, that means this multiplied with this AB, in between the two it is summation now, that is B plus A is equal to, now what is it? Now the one which was addition becomes product, so now it's going to be BA and it will be addition between the other two, that is A plus B. You need to observe what the relation is. The first one says product between the first component and the last component multiplied with sum of the remaining two components. This is your left hand side. Right hand side becomes just the reverse. That is, the components that had multiplication is now having addition between them, and the components that had addition is now having multiplication between them. So this is what we have. Now the question is whether it is true or not. That you have to justify. How will you justify? Which is true or definitely? Which is always true or valid. You can use the word valid also. Why? Because B plus A is equal to A plus B, and because AB is equal to BA. So therefore their product on either side must be equal. So that is why this equation that I have is valid. So I will say therefore AB is related to AB by the given relation, that is R is reflexive. Next comes, we will show whether it is symmetric or not. Okay. How will you show whether it is symmetric or not? Required to prove if AB is related to CD, then I have to show whether CD is also related to AB or not. This is what I have to show. In other words, if what is AB related to CD? AB into B plus, AB into AD, AD into B plus C is equal to BC into A plus D, whether it implies that, what will I have? First component into the last component, CA into D plus B is equal to, now the reverse, that is this one will become product now, DB into C plus A. Whether it is true or not, that is what we have to justify. Okay, this is what we have to justify, whether it is true or not. So how will we proceed? Now, D plus B is something which we have to obtain. Okay, so we will do it the either way round. That is, since AB is related to CD, we have assumed that AB is related to CD, so by assumption, and therefore it implies that, I'll write the equation, AD into B plus C is equal to BC into A plus D. This is true, okay, because I'm assuming that it holds. Now what is happening to CD related to AB? Let's see that. I think I'll give it an equation number 1. Now, when I write CD is related to AB, it implies that CB into D plus A, I've already written over there. What did I write? CB into C, wait 1 minute, I wrote wrong over here. C B into D plus A is equal to, now the reverse, DA into C plus B. Be very careful, okay? It's between the first component and the last component. Here it is what? AD, first component and last component. First component of the first pair, last component of the second pair. Similarly, it should be CB into sum between the rest and then the reverse. Okay, so CD related to AB implies that it is CD into D plus A, which is related to DA into C plus B. Is it true or not? That is what we will say. Okay. This LHS over here can be written as BC into A plus D. And this relation over here, RHS, can be written as AD into B plus C. Why? Because multiplication and addition are commutative. Okay, so you will write, since multiplication and addition are commutative. This implies this and LHS implies this. Just a partition in between, which is true by equation 1. Where will I write? I'll write on top. But by equation 1, BC into A plus D, that is LHS, is equal to AD into B plus C. Okay, hence CB into D plus A should be equal to DA into C plus B. That is, CD must be related to AB if AB is related to CD. Hence, R is symmetrical. This will be your